Since we just covered capacitors and capacitance, I thought it would be advantageous if I gave you a look at a special type of circuit called an RC circuit. And RC in this context means resistance, capacitance. So the basic premise here is that it is a circuit with a battery, one or more resistors, and one or more capacitors. So let's take a look at the absolute bare minimum example, which would be a circuit with one resistor, one battery, or one source of electromotive force or voltage, and one parallel plate capacitor. Okay, so I'm going to draw like this. So let's say that we have a battery here. So we have a positive terminal here, and then we have a negative terminal here. And then let's say that attached to this, we have a resistor. And then going across here, we come down to a parallel plate capacitor. So here is the top parallel plate. Here is the bottom parallel plate. So this would be termed C. This would be termed either V, V looking like this, or an epsilon. Epsilon would denote EMF or an electromotive force, and V would denote voltage, and resistors are typically labeled with Rs. Okay, so then we could complete the circuit like this. And just for simple purposes here, we are going to assume that the copper wires that we are using in this circuit have a resistance that is effectively nothing. Okay, so what would happen? So my question to you is, what would happen when we connect the battery to the rest of the circuit? Okay, well, we have a positive terminal here, and we have a negative terminal here. Okay, so assume that you have a bunch of positive charges that are gathered over here, okay? Now, what would happen when the battery is connected to the circuit? Well, we know that like charges repel, so all the positive charges would begin to move away from this terminal of the battery. And we know that whenever we speak in terms of circuits, we're always assuming that the way that the current is moving is the way that all the positive charges are moving. So if all the positive charges are moving away from this terminal of the battery, then we would show that the flow of current goes like this. So as we have all these positive charges flowing up to the right and down to the top plate of the capacitor, now understand that there's a dielectric in here. So there is a dielectric that is separating the two plates of the capacitor. So when they get charged, they do not attract one another. So we have positive charge going here. So soon enough, we have positive charges collecting on the top plate of the parallel plate capacitor. Now, as you could probably imagine, the exact opposite is happening over here. So we have a negative terminal here. So naturally, positive charges that would be gathered over here on the bottom plate of the parallel plate capacitor would be attracted to the negative terminal of the battery because unlike charges are prone to attract one another. So we have a flow of current moving in this way. So positive charges are moving toward the negative terminal of the battery. Well, as you have positive charges migrating to the left here, then what happens is that you have negative charges that are left on the bottom plate of the capacitor. And now what have we discovered? We have positive charges on the top plate of the capacitor, and we have negative charges on the bottom plate of the capacitor. And now we have established a potential difference. So there is now a potential difference. We have now established a potential difference between the top plate and the bottom plate of the parallel plate capacitor. And it is helpful to know that this migration of charge around the circuit will continue until the voltage or the potential difference of the capacitor matches the terminal voltage of the battery. So we could write the flow of current in various directions will persist until the electric potential difference of the two plates of the parallel plate capacitor matches the terminal voltage of either the battery or the voltage source. So for example, if the battery had a terminal voltage, we could write this as V sub t is equal to 12 volts, then this migration of charge would continue until the potential difference of the two capacitor plates is equal to 12 volts. I hope this helped, and I will see you in the next one.